Welcome to this video on how to set up the LSTM network. After completing this video, you will be able to explain how to set up the LSTM network.
Sophie, I understood the difference between LSTM and ANN and would like to use the LSTM model for portfolio optimization. Can you help me set up the LSTM network?
Sure, John. Let me explain to you with a problem statement. Consider this problem statement of creating a portfolio of 4 assets with appropriate weights for each of the assets. Let's see how we can set up an LSTM network for this problem. Since we want to calculate weights for 4 assets, the size of the output layer would be 4. Since the value of weights would be between 0 and 1 with the sum of all weights as 1, we will use the softmax activation function for the output layer. Let's consider returns as input to the input layer. The input layer is 3-dimensional. One of the dimensions is the number of input features passed to the LSTM model. The other dimension is the time steps. If you are using a lookback of 20 days to calculate the input features, then the number of time steps would be 20. The other dimension is the batch size. The batch size represents the number of different portfolios or scenarios you want to analyze simultaneously. If you set the batch size to 10, it means that during each training iteration, the model will analyze and update its weights based on the performance of 10 different portfolios or scenarios at the same time. In addition to input and output layers, you can also have hidden layers added to the LSTM network. The input data from the input layer passes through hidden layers, and then to the output layer to calculate the weights of the assets in the portfolio.
How will the model learn if these weights are appropriate or not?
This is where the loss function comes into play. The loss function helps to evaluate the weights calculated by the LSTM network. John, what is the desired portfolio?
Is this the portfolio with a higher Sharpe ratio?
Exactly. So we create a loss function based on the Sharpe ratio.
But Sophie, don't we try to minimize the loss function? Does it mean we minimize the Sharpe ratio?
We create a loss function that outputs negative Sharpe. Hence, the Sharpe ratio is maximized while the loss function minimizes during the training of the LSTM network. To summarize, the LSTM network has a 3-dimensional input layer. The shape of the output layer represents the number of assets in the portfolio. The softmax function is used as the activation function for the output layer. The input data of the model passes through the input, hidden, and output layers to calculate the weights of assets. The custom loss function based on the Sharpe ratio is used to facilitate learning of the LSTM network from input data to calculate the best possible weights for the assets in the portfolio.